Bismillahirrahmanirrahim. Assalamualaikum and good morning. Okay, today I'm going to go through one example, exercise 3.4 in the book, okay, where we have problem on equilibrium for 2D case. Okay, in this problem, exercise 3.4, if you are given a system, a cable system, you have cable AB connected to cable BC and cable CD, and then we have two masses attached at point B, 10 kilogram, and then the second mass at point C, hanging from point C, 25 kilogram. Okay, so the system is in equilibrium, you are given, and then you are asked to find tension in cable AB, and you have to find theta. What is theta value? The angle of that cable AB from horizontal axis. Okay, so remember, okay, so for this equilibrium problem, okay, what you need to do first is to draw your FBD. Okay, so you have to draw your FBD. Okay, you can start with at this point C. Okay, at point C you have this mass 25 kg, so you can take, okay, you can draw, this is point C, example. Okay, and then okay, from point C you have weight pointing downward. Okay, you can just write W, which is equal to mg, mass times the gravitational force, so 25 times 9.81. Okay, then from there point C we have the cable CD at 30 degree angle. Okay, you can have actually that let me see, where's my okay, this is 30 degree. Okay, and then we have tension TCB. This is tension TCB from this point to point B. Okay, you can just write it TCB. So this is your FBD, free body diagram for point C. You have one force, the weight pointing downward, and then you have the tension TCD, 30 degrees from horizontal, and then we have TCB, tension TCB due to the cable CB at 45 degree. This is 45 degree, meaning you have a zigzag, so this will be 45. Okay, so this is your FBD, so showing the forces acting on your particle. Okay, particle C for example. Okay, so once you have your FBD, you have to decide whether you want to use the triangle method, okay, where you draw the triangle. Because we have the three forces involved, you can proceed to use the triangle method, or you can also use the rectangular component method, okay, where we resolve the forces into the X and Y component. Okay, let us try. Okay, so you have your FBD. Okay, so now we are looking for to find you can find TCB and TCD first. Okay, so this is the FBD. We'll proceed now. For example, if you are using the triangle method, okay, you have your, just now, TCD, this is TCD, okay, and then we have the TCB, 45 degree, TCB, and then we have the weight. It must be pointing straight. Okay, so this is your MG. This is your TCB, and this is your TCB. Okay, so you have the system, and since you can find the angle, this is 30-degree angle. Okay, then we have the weight, which is vertical, so meaning this will be 60. Okay, and then we have 45-degree angle from point B, okay, to TCB. This is 45 degree. Okay, 45 degree, so meaning the other is also 45. Okay, so since 60, 45, so this would be just 105, 75 degree. Okay, so there you go. Okay, you have your mg, you have the value mg already. Okay, you have two angle. Okay, so you can use the sine rule. Okay, for example, you go sine 75 over sine 75 over mg equal to sine 60 over TCB. Okay, so using this sine rule, okay, look for TCB now. TCB. Okay, so just rearrange, you will get, okay, sine TCB equal to there you got TCB sine 60 over sine 25, okay, times mg. Okay, so you can solve for TCB. You will have TCB equal to sine 60 divide by sine 75 times mg, 75 times 9.81 219.89. Okay, you get your TCB, okay, 219.89 Newton. Okay, so once you have your TCB, actually, okay, we need to proceed to the other point. Okay, we need to look for point B, the forces acting on point B. Okay, so you have your TCB 219.89. So what you need to do next is to draw your FBD. Actually, draw your FBD for point B. Okay, at point B, FBD, point B, okay, you have your 10 kg going to point downward. Then you have your TBC, so this is a TBC, so this is your okay, once you are done with your FBD, okay, we can continue by drawing your triangle using the T forces. So you have the vector force TBC, this is your TBC, then connecting TBC, you have your TAB, okay, that is the angle theta, okay, TAB or TBA, TAB, and you have your weight representing this force. So 10 kg times 9.81, you get 98.1. So this is the third vector force. So once you have this information, actually you can get this 135. Okay, since we have this vector force TBC given 45 degrees, so if you have your zigzag is 45. So this is 45. Okay, so vertical 45, and then you know this is another 90 degrees, so total up of 135 degree in that angle from the vertical vector force W. Okay, and since we have one angle and then we have the value for TBC already calculated just now, TBC is equal to TCB that we have calculated from the first FBD just now from point C to 19.89 Newton. So we have TBC, and then we have the value, the magnitude for W, which is 98.1 Newton. So once we have these two information and we have one angle given already, known already, so we can apply cosine rule. Okay, we can apply cosine rule. Okay, and since we are looking for TAB now, we can find TAB. Okay, TAB square equal to W square plus TBC square, okay, minus 2W TBC, okay, cos 135. Okay, so we have this value W, we have TBC, we have W, TBC and everything, so we can solve for TAB. TAB, okay, putting in all this value W, TBC and cos 135, we get TW, TAB 884, 81.5. Okay, so we take the square root, okay, and then TAB, okay, we square root, take the square root for this value, you get TAB to be 297.45 Newton. Okay, so you got your TAB. Okay, so we have TAB, we have TBC, we have W. Okay, and then now we can apply once there's a cosine rule. Okay, to TAB we get TAB equal to now TAB we have 297.45 Newton. Okay, so we can now apply sine rule. Okay, sine rule to get the other angle. Looking for theta now. Okay, applying sine rule, we are going to have. Okay, we are going to have. Okay, for example, okay, this is we give put this one as alpha. Okay, we have sine alpha over TBC. Okay, the opposite vector force equal to using 135 sine 135 over TAB. Okay, we're looking for alpha now. Okay, we get sine alpha equal to sine 135. Okay, sine 135 divided by TAB okay, times TBC. Okay, this one give you sine alpha, you get okay, sine 135, what 0.5, okay, so already I calculated already 0.5 2 to 7, okay, and then you give the inverse of 0.5 to 7, you get alpha, okay, alpha equal to 31.5. Okay, so once you get your alpha 31.5, okay, so you can calculate your theta. Okay, theta is just, okay, once you get your, okay, you get your alpha, so theta is just okay, 90 degree minus alpha, okay, 90 degree minus 31.5, okay, you get your 58.8, right, 0.5, okay, so you get your alpha, your theta. So that's it. So you have your theta value 58.5, okay, and your TAB value is 297.45. So these are the two answers. Okay, so this is using the method of triangle. Okay, applying cosine rule and sine rule. So it should give you the answer there. Okay, so please make sure you understand all the steps. Okay, and thank you very much. I will stop here. We'll see you again. Have a nice day.